Today we are going to find the wavelength of a transverse wave in a straight string. Now let's consider we have a straight string. The length of this string is given as 1.6 meter and the mass of this string is given in the numerical as 300 gram. It is stretched with a tension of 400 Newton. We will determine the wavelength of transverse wave, where the frequency of this transverse wave is given as 40 Hz. Now for determining the wavelength, first we will calculate the velocity of the wave in a straight string, and velocity of a transverse wave in a straight string is equal to under root t divided by mu. We have already derived this equation in one of our previous video, where t is tension and mu is the mass density, linear mass density, and linear mass density is equal to mass per unit length, mass of the string, and divided by the length of the string will give us value of mu. So substituting the value of linear mass density in the velocity equation, we will get under root t divided by ml, and rearranging this equation, this l will go to the upside and we will get t multiplied by l divided by m. Now the value of tension T is given as 400 Newton and the length is 1.6 meter, where the mass is given as 300 gram. Dividing and multiplying this 300 by 1000, we will get the answer 0.3 kilogram in SI unit. So the mass is 0.3 kilogram. Substituting these values, T is equal to 400 Newton, length is equal to 1.6 meter, and mass is equal to 0.3 kilogram. Now multiplying 400 Newton with 1.6 meter, we will get 640 dividing by 0.3, and dividing this 640 by 0.3, we will get under root 2133.4. Taking under root on this term, we will get 46.18 meter per second. And this 46.18 meter per second is the velocity of the wave in this straight string. Now we will calculate the wavelength. For calculating the wavelength, we know velocity is equal to frequency times lambda. In terms of frequency and wavelength, the velocity of the wave is equal to frequency multiplied by wavelength. Here, this velocity was in terms of tension T, and mass and length of a straight string. But here, this was specifically for the transverse wave, while this one is a general wave velocity equation in terms of frequency and wavelength. So, for calculating the wavelength, we will divide both sides of this equation by frequency. We will get lambda wavelength is equal to velocity divided by frequency. We have already calculated the value of velocity, which is 46.18, and the frequency value is given in the numerical, which is 40 Hz. Substituting the value for velocity, 46.18 meter per second, and the value of frequency is 40 Hz, dividing 46.18 meter per second by 40 Hz, we will get 1.15 meter, and this is the required wavelength in a straight string, which is 1.6 meter length and mass is 300 gram. That's it. Thank you for watching, and do not forget to subscribe easyedu for more videos.